For this problem, we need to use implicit differentiation to find dy dx, where we are given this equation that's in terms of both x and y. Okay, so first off, I need to use the product rule on this first term. So remember, with implicit differentiation, we need to take the derivative of each term separately with respect to x. So I have both an x and a y in the same term multiplied, so I'm going to use the product rule. So I'm going to set my first piece to negative x, so u prime is -1. And then I have v, where I'm going to set that equal to y. So v prime, again, we're taking the derivative with respect to x, so the derivative would be dy dx. Okay, so cross it, and we end up with -y, so that's the u prime times v, -1 times y, minus, because I have a negative right here, x times dy dx. So again, that was the derivative only of this first term. So now take the derivative of -2, which is just 0. And then I need to take the derivative of x over 7. Now remember, that's the same thing as 1/7 x. So with respect to x, we just get 1/7. All right, so my next step is to solve for dy dx. So let's add y to both sides. So I get -x dy dx is equal to y plus 1/7. And then I'll divide both sides by -x to get y plus 1/7 divided by -x. Now it's kind of a weird way of writing the problem because I have this fraction within the overall rational expression. So, of course, you can leave the answer like this, but I think it looks a little bit weird. So I'm going to multiply a 7 on top and bottom. Now the reason why I did that is because I have a 7 in the denominator down here. So when I distribute, I end up getting 7y plus 1. So it gets rid of the fraction. That was the whole point. And then in the denominator, I will get -7x. So this is a nice way of writing the problem. Of course, you could have left it, and that's perfectly fine as well.